All right, today we've got a real scientific detective story for you. Imagine this. The crime scene? It's a microscope slide. The victims? Thousands and thousands of tiny crystals. And the mystery they're trying to solve? Well, it's a really painful medical condition that affects a lot of people.
And believe it or not, it all starts with this flower. It's called cat's whiskers. For generations, it's been used as a traditional remedy. But, scientists wanted to know, does this thing actually work? An even bigger question, how on earth could they prove it?
So to get to the bottom of that, we first have to understand the problem it's supposed to be solving, and that is the formation of kidney stones. Okay, so here's the deal. Inside our bodies, certain minerals can form these microscopic crystals in our urine. Now, a few tiny crystals, not a big deal. But if they start to grow and clump together, that's when you get painful kidney stones. So the real key here, the goal, is to stop that growth before it starts. And this is where our plant comes back into the picture. Its scientific name is Orthocyphlon staminaeus, but it's been the go-to herbal solution for urinary problems in Southeast Asia for, centuries. So researchers decided to put it to the test. They set up an experiment to see if all that traditional wisdom actually holds up under a microscope. Right. So, how do you even test something like this? The scientists needed a way to literally watch these crystals form in real time, with the herbal extract and without it. What they did was pretty clever. They basically created this miniature laboratory on a single glass slide. They coated it in a special gel, and in these tiny little wells, they put in the basic ingredients for kidney stones, things like calcium and oxalate ions. The idea was that these would then start to grow into crystals, right there on the slide. Now, to make this a fair fight, they split the slide into 3 different lanes. First, you've got the blink lane, where the crystals could just grow wild, no interference. Then there was the control lane, which had sodium citrate. That's a substance they know stops crystal growth. And finally, the sample lane, which had our cat's whiskers extract. All they had to do then was wait and see what happened. But here's the thing. What they got back? It wasn't a simple, yes, it works, or no, it doesn't. No way. It was an absolute avalanche of data, a flood of tiny individual clues that was just overwhelming, almost impossible to make sense of. I mean, think about this. Throughout the experiment, they took all these microscopic images and measured every single crystal they could find. And the grand total? Over 17,000 of them. We're talking about a massive data set here. And it gets even crazier. For every single one of those 17,017 crystals, they didn't just measure one thing. Nope, they measured 6 different things to describe its size and shape. Things like its area, its roundness, you name it. Do the math on that. That's over 100,000 individual data points. This is the classic detective's nightmare, right? You've got 6 different variables for thousands and thousands of clues. You don't have a story. You just have noise. The answer is buried in there somewhere, but you can't see it. So, how do you find it? Well, you bring in the specialists. And in this case, the detectives aren't people in trench coats with magnifying glasses. They're powerful data science algorithms. Basically digital detectives designed to find patterns in all that chaos. So the first detective on the case is a technique called principal component analysis, or PCA for short. You can think of it like a master detective who walks onto a messy crime scene, and instead of getting lost in every little detail, they just ask, okay, what are the most important things happening here? What are the biggest differences? PCA does that with data. It takes this super complex data set and just boils it down to the most important patterns, what they call principal components. And what PCA did was brilliant. It looked at all 6 of those complicated measurements, and it realized they could basically be summarized by just 2 simple ideas, size and shape. Just like that, this chaotic 6-dimensional problem became a simple, elegant 2-dimensional one. It literally gave the scientists a whole new way to see their data. Okay, so detective number 2 was an AI called a self-organizing map, or SOM. Here's a cool way to think about it. If PCA finds the main plot of the story, SOM is the one that draws you a picture of it. It takes all those individual crystals and arranges them on a visual map, almost like a landscape. It automatically puts similar crystals next to each other, so you go from a boring spreadsheet to something you can actually explore with your eyes. So now, with these 2 digital detectives on the case, the story that was hidden in all that data finally started to come out, and the punchline was, well, it was crystal clear. Okay, take a look at this. This is the PCA plot. Remember, the line going across the bottom, that's size. The line going up, that's shape. Now, I want you to watch the white shapes. Those are the untreated crystals, the blank sample. See how from 1 hour to 24 hours, they just march steadily to the right? That right there, that's the story of unchecked growth. They're just getting bigger and bigger. But now, look at the control and the sample. See that? Their journey to the right is completely stopped. They're stuck over on the left side of the chart in the small size zone. The story here is just undeniable. Both the stuff they knew worked and the cat's whiskers extract, they both stopped the crystals from getting bigger, period. And then the SOM, our AI sketch artist, tells the exact same story, but in a totally visual way. On the left, that's the map for the untreated crystals after a full day. You see all those big white hexagons clustered up in the corner? That's the big crystal neighborhood. Now look at the map on the right. This is the one with the herbal extract. It's almost all dark blue background. The growth has been totally shut down. It's so obvious.
And finally, we can put a hard number on it. The scientists came up with something called an inhibition index. Basically, 0 means it did nothing, and 1 means it stopped growth completely. The known control substance, it scored a 0.255. And the cat's whiskers extract, it scored a 0.290. So yeah, it was just as effective, maybe even a little bit more so.
So what's the big takeaway here? I mean, the finding itself is super interesting, but how they found it, that's the really revolutionary part.
So yeah, case closed. The traditional remedy actually works. But the real hero of this story, if you ask me, isn't the plant. It's the process. It's this incredible ability to take a huge, messy pile of data and turn it into a simple, visual story that anyone can look at and just get.
And really, this gets to the very heart of what modern data science is all about. It's not just about predicting the future. It's a tool for seeing. It's a way of translating this overwhelming complexity into something that makes sense on a human scale. It lets us find the narrative that's hidden inside the numbers. Which kind of leaves us with this one last big thought. I mean, if a clear story about healing was hidden inside 17,000 tiny crystals, what other crucial stories are out there right now, buried in data? Stories about our health, about our planet, about our future, just waiting for the right detectives, the right tools to help us finally see them?